Okay, so what's going to cause your PACS system to go down? I'm so glad you asked. In 2012, RSNA did a study of PACS downtime causes, and here's what they found. Computer hardware accounted for 24%. Hard disk drive failure, 26%. Right? So combine those two. What do you got there? 20, 40, 50%. Half of all PACS downtimes were caused by computer hardware failure or a disk drive failure. Communication processor, 11%. Data communication network, 10%. Software, 22%. Human error, 6%. 6% of your downtime could be caused by humans. Very dangerous creatures. 50%. Did you see that? Of PACS downtime events are caused by computer failure or hard disk drive failure. If you do a good job checking your core PACS components, you can reduce the risk of significant downtime by 50%. Always be checking the core of your system. In addition to doing good PACS quality control, you want to evaluate your systems and processes for points of failure. There are two commonly used phrases for points of failure: single point of failure and single threading. A single point of failure involves a system where one component does a critical task. For example, what if a PACS only had one database server? If the database server goes down, the whole system crashes. That would be an example of a single point of failure. Single threading is when only one person has all the data or a critical component of the data. What if only one person in the office knew the password to the database server? If the database server needs maintenance and that person is unavailable, then everything waits until that person is available. Points of failure need to be eliminated through redundant systems or processes. Two terms that often get used interchangeably but have very different meanings are business continuity and disaster recovery. Business continuity involves a small-scale failure that could be quickly overcome with a redundant system. For example, if you have a cluster database where node A is unresponsive and the system automatically fails over to node B, that's an example of business continuity. Business continues, it's transparent to the user. Even though you know there's a failure and you got to go fix node A, node B is still keeping everything running in the background. It's automatic, there was no humans involved, and transparent to the user. That's how you kind of define business continuity. Disaster recovery involves getting the system back online after a major disaster. This is a process or system to get PACS up and working after the data center has had a fire or some other major catastrophe has happened. As you can see, these are two different events which require separate strategies. So, disaster recovery, right? There's a fire at the data center. The entire PACS system has been burned to a crisp. You got to get it back up and running. Well, hopefully, you have a disaster recovery system that involves a copy of your database server, a couple of DICOM servers, an IMS, all those elements you would need to get your PACS back up and working in a different building, in a different city, in a different state. Maybe it's in the cloud, wherever you're keeping it. That's a disaster recovery system. And as always, thank you for watching.